Hello, my name is Dang Bilun. Here's the project that I've done for my 10.4 hand distinction task, which is the Swift cipher cryptography and techniques in decrypting Swift cipher using Ruby. As we all know, cryptography is an integral part in protecting our data in the digital era. Without it, our message, data, and informations will be at risk of being compromised and then being used for malicious intents. In this project, I will discuss about cipher, which is the most well-known, easy to applicate, and simple encrypting techniques. Several decrypting techniques of the mentioned cipher will also be discussed. From the message that was sent by a general to his soldiers in ancient Rome to the advanced modern security system that ensures cybersecurity for billions of people. The importance of cryptography has never been illegible. The art of cryptography is to render a piece of information so that it will become unrecognizable to an undesirable individual. The whole concept of cryptography revolves around the word plain text, which is the meaningful intended message that is sent by an individual, and ciphertext, which is the unreadable, sometimes meaningless message that has been encrypted by the sender. Let's have a look at an example of cryptography, which is the Swift cipher. A Swift cipher is an action of encrypting a message by replacing its letter with another letter that is some fixed number of positions further along in the alphabet. That may seem a little bit mouthful. Firstly, let's have a look at an example. Firstly, we assign a number for each letter in the alphabet. Like the letter A will be assigned to value 0. Letter B will be assigned to value 1. And accordingly, the letter Z will be assigned to value 25. So, as we have assigned the number to a letter, it can now be shifted by a fixed value. For example, the shift value will be 4 in the example. In the example, the letter A, which has an initial value of 0, has been added 4, thus becoming a letter E, which is the fourth letter in the alphabet. If we have a blank text such as Swinburne with a key of 4, the ciphertext would be WAMRFYVRE. After a process of replacing the letter, we have successfully encrypted the word Swinburne. One of the most famous versions of Swift cipher and supposedly one of the earliest known cryptographic systems were used by Julius Caesar. Therefore, people usually refer Swift cipher to Caesar cipher. The encryption and decryption of the Swift cipher is extremely simple. As we have mentioned above, each of the letters will be assigned to a known number, and accordingly to the end of the alphabet. Therefore, the encryption and decryption of a letter can be described mathematically as EN, which is encryption process of a plain text, equal to X plus N modulo by 26. Similarly, the decryption formula are as follows. DN, which is the decryption process of a ciphertext, will be equal to X minus N modulo by 26. It is said that Caesar has selected 3 as a key value or shift value of his cipher system. Thus, every letter in the alphabet will be shifted by a value of 3. Suppose we have a plain text Rome. It will be enciphered as 17 plus 3 modulo by 26, which is 20, and 20 is the value of the letter R. Value of 3 in the alphabet. Suppose we have the plain text of Rome. It will be enciphered as 17 plus 3 modulo by 26, which will be 20, and the number 20 is assigned to the letter U. 14 plus 3 modulo by 26 equals 17, which will be the letter R. And the letter R is assigned to the number 17. Similarly, we'll be able to encipher Rome to URPH. The process of deciphering the ciphertext URPH would not be so different. We have the the letter U assigned to the number 20, and 20 minus 3 multiplied by 26 will be 17, and that will be the letter R. 17 minus 3 multiplied by 26 would be 14, which would be the letter O, and accordingly the ciphertext URPH would be deciphered to Rome. Now let's have a look at the code implementations for the encrypting and decrypting process of a SHIFT cipher. First, we'll be entering the plain text and the key for the SHIFT cipher. The plain text will be this test case, and the key will be the letter here. In the class SHIFT cipher, we'll be initializing 26 uppercase letters in the alphabet and 36 lowercase letters in the alphabet. We'll be initializing the encrypting text. The first process of SHIFT ciphering is to check whether the letter in the plain text appear in the list above. If it does appear, then we'll be shifting a letter to the right of the alphabet in equivalent to the initial key. Then we'll be concatenating the letter into the encrypting text and entering the next letter. We'll be checking every single letter in the plain text. And if we have checked all the letters, then we'll be returning the encrypted text. Similarly to the decrypting process, but this time we'll be using the ciphertext, not the plain text. Now let's move on to some decrypting techniques. With only 26 possibilities, which is the total number of letters in the alphabet, a brute force attack will be detrimental to SHIFT cipher. A brute force attack will employ trial and errors to guess the possible key for particular cryptography. It will be similar to the decrypting process, which I have mentioned earlier. However, this time we will be not only decrypting one version of the plain text, we will be decrypting every possible versions of the plain text. As you can see, we have been decrypting 25 times plus 0, which is 26 times, and we'll be able to spot the versions that has the meaning, and 17 will be the key for this SHIFT cipher. Similar to the brute force attack is the known plain text attack. A known plain text attack will rely heavily on the frequencies or appearance of a letter in the plain text to work effectively. In this example, the word "the" usually appear in an English sentence, so we use this as our known plain text. We have with the ciphertext here, we have predicted the key is 17, and the program will ask us whether we want to decipher the ciphertext using the predicted key. Now let's try it. And we have successfully predicted the ciphertext without knowing the key. This can be used several times to guess the meaningful message of the ciphertext. Data security is becoming increasingly important in the digital era. Our data is at risk of being compromised, modified, and impersonated by unwanted individuals. Although the use of cipher in modern data encryption has become unpractical, the knowledge and understanding of this method can provide a fundamental concept for cybersecurity enthusiasts. That is also the end of my presentations. Thank you for your listening.